Hello again. Welcome to Governor Mifflin Coding Club. This is lesson 3 on LEDs. This is going to be on RGB LEDs and basically changing colors. And we're also going to explore using basically creating a nightlight using a light sensor. And we're going to do color changes on the RGB LED. So let's get started. What you want to do is get kit 3 out and it'll look like that. Now again, all these kits are pre-wired, so you really don't need to work on any hardware at this point. You just want to plug in and start programming. Put this little diffuser on the RGB. Well, actually, let me show you what it is first. Now, on the bottom of the kit, you'll have your lesson plan. We'll pull that out as well. Put this aside for a moment. On your lesson plan, again, you want to read through your lesson plan. Again, this is going to be for RGB LEDs. We're going to go through arrays. We're going to learn about an ambient light sensor, basically a light sensor that can create a night light, if you will. Again, your instructor is going to go over your concepts of the RGB LED, and then we're going to go through 2 lessons. One was going to be an ambient light sensor. Actually, the first lesson is going to be using a potentiometer to change color. So we're going to continue using the potentiometer from the last lesson, and we're going to use it to change the colors of the RGB LED. And next step after that is we're going to create a night light. So let's get started with the programming. I'm going to plug the Arduino in. Now what you'll see on the board itself, we have the RGB LED right there, and an RGB LED has basically all 3 LEDs in the same housing, and there's 3 resistors here, and those LEDs are plugged into ground, and the other end is on pins. Let's see, we're on pin 11, 10, and 9. Why did I pull that out? Okay. Again, you'll see the RGB on the end here, and you'll see the resistors, and they are connected to pins 11, 10, and 9. The reason they're on 11, 10, and 9 is because of the pulse width modulation needed to control the colors of the RGB LED. We have a potentiometer on the side here. We have a light sensor on end here. And this resistor here is a pull-down resistor, so there's no... what pull-down resistor does is it makes sure there's no other energy when we're not using it, so it doesn't hold energy in there, so it basically just drains everything down. So those are the concepts, or those are the parts of the breadboard that we're going to be working with today. Now let's get started with programming. Let me pull up a coding program here. Okay, there's an Arduino IDE setup. It's a new one, so let's get started on the programming part. First, what we're going to do is we're going to do the color change. Now, color changes, the RGB LED obviously has a red component, a green component, a blue component, and we are going to initialize those variables at the top here. So again, at the top section of your program, you want to initialize all your variables. So constant, integer, and we're going to call this red pin. And we're going to make that equal to pin 11. constant, integer, and the next one is going to be green pin. And I'm going to make that equal to pin 10. Constant, integer, and we're going to do the blue pin. And we're going to make that blue pin equal to 9. And let's just comment this. Define RGB for each color pins. Okay. So we've defined the Okay, so we've defined the pins on the Arduino matching the red, green, and blue component of the RGB. Now next we're going to define an array of colors. So each color can have a different value, which then we can control to mix up and change colors. So initialize red value. We're going to call this red value. Okay, and I'm going to put it inside brackets. That's a, oops, wrong brackets. Okay, so it's a 7 array bracket. Now we do the curlies. Inside the curlies, we're going to have 255, 255, 255. 0, 0, 7, 5, and 238, and that closes it. Semicolon, and we're going to initialize green value, or initialize the green value, and same thing is going to be array of 7, and that's going to be equal to, I'm going to do curly, both curly brackets so I don't forget the last curly bracket, 0, 165, 255, 128, 0, 0, 130. And then initial variable for the blue value. Again, these are components of color that we're going to create a rainbow with, so we can change all the colors with the potentiometer. So for the blue value, we're going to start at 0, 0, 0, 0, 255, 130, oops, 238. And not important to know what the array values mean at this point, just copy them as they are. Next thing we're going to put in is the pot pin. So, oops, I spelled value wrong there. Did I get the rest right? Yes, I did. Okay. So we're going to put in a constant for the pot pin, the potentiometer that we used before, and that's at the same pin position. That's A0. Okay, and actually I'm going to comment this out, declare analog pin A0 for potentiometer. Very good. And actually we're going to comment this out. This is the array for rainbow of colors. Okay. And while we're at it, we're going to put the light sensor in here too. So and I forgot to put the integer. Okay. So for the light sensor, we're going to declare a value for that, or a variable for that too. And that's going to be light sensor pin, and we're going to put that on pin A1. Clear pin for light sensor. Okay. Get back to the front here. Oops. There we go. Make some space, make it a little easier to read. And we also want to put a constant back in for potentiometer value. Pot value, and we don't need to put a number on that at this point. We just want to declare that as a variable that we're going to use momentarily. Okay, now in your setup, we're going to declare as again as your pin modes. So basically we're going to make your RGB pins as output. So the red pin, is that what we called it up here? I didn't capitalize that. Red pin. So red pin is 11, green pin is 10, blue pin is 9. So red pin, we're going to call that an output. Pin mode, capital green pin is an output. And pin mode blue pin as an output. Okay, so we've declared our pin modes for our pins. Now, okay, we can comment that. Okay. Now next we're going to put in, actually we're going to turn on a serial port. So what a serial port is communications. Oops, it's not a comment. What a serial port is communications, and you don't need a semicolon there, that you can talk to the Arduino through the serial port, either input or output. And how you do that? Actually, I don't think it's. Yes, I do. This is lowercase, and that is capitalized. There we go. Serial port. Serial begin, and you want to use your baud rate. This is how fast the communication line is going between your computer and the Arduino. And that's it for the void setup. Let's go to void loop and start our program. First thing we're going to do is we're going to get that pot value again. So pot value is we already declared it as a variable. That's going to be equal to the analog read of the pot pin again. So as we're turning the potentiometer, we're going to read the signal from that potentiometer, and we're going to declare it as a value as pot pin. That's our variable. Next, we're going to convert that value to a color index. And how we do that is, get to the right spot here. Here we go. Comment that. Convert the value. Now, int color index, and we're going to use the map function again. Map is equal to pot value, which is what we just read. And again, the analog read goes from 0 to 123. I'm sorry, 1023. And then the pulse width modulation, the output is going to go from 0 to 255. Actually, we're going to go from 2 to 6. Okay. Now here's where we're going to use the, oops, let me use a space here. There we go. Here's where we're going to write the serial port so we can understand what we're reading here. So we're going to write out the color index, and how we're going to get it is through the serial port. So serial print line is equal to POT value semicolon serial print line, oop, missed a dot, and lowercase. Okay. And color index. So that's a double check. We're going to, if the program doesn't work, we'll be able to see through the serial port what the numbers actually mean. Next, we're going to set the appropriate red, green, and blue value. And let's document it that way. And turn my clamp lock on for some reason. Appropriate red, green, and blue values. There we go. Okay. And how we're going to do that is analog write. Analog write, and we're going to do the red pin. Actually, I think it was lowercase. Yes, red pin, and red value color index. Okay. And close close bracket there, semicolon, and we'll do the same thing for the green and blue. Green pin. Green value. Color, nope, color index. And close bracket, semicolon. All right, and for the blue. Blue pin. And I got the green wrong there. Okay, there we go. Blue value. Color index. Close bracket, semicolon. Okay, so we've set the analog rights for the output to the blue value and color index. So what these are doing is, as we read the potentiometer value, these are changing it to the color index to map it, and then that value is 0 to 6 going into the analog right for the red pin, the green pin, and the blue pin, which are actually on the digital pins, but they're going to act like analog outputs. So let's compile it. Well, it wants to save, so we'll compile it. Okay. And we have something wrong. Or we're missing a semicolon. A comma, expected a comma or a semicolon before int. Oh, okay. We missed a semicolon up here. There we go. Let's try verifying again. Missed something else. What did we miss? Pot pin. I spelled pot pin wrong. Capital P, I believe. Yes. Let's try that again. Oh, another one. Pot value. Okay. It's supposed to be INT, pot value. Okay, let's try that again. Okay, everything green, looks good. Let's upload it. Oh, let's double check, make sure we're on the right port. Now we need to be on port 13. Okay. Upload. Okay. Let's put a little diffuser on top here so we can see what colors we have a little bit more clearly. Here we go. All right, I'm going to move this over a little bit. Actually, let me get this out of the way for you. Okay. We'll bring this guy over. I don't know if you can see that. That's a greenish, a red, purple. Okay. So we have 7 different colors that we're going through. We're going through a red, a purple, sort of like a lavender there, back to the purple, back to the red, green, blue, purple. Okay. There we go. So turning a potentiometer changes to 7 different colors. And that's where, if we go back to the, let me go back to the program here. That's where your array comes in. So when we're going through 7 different values of red, 7 different values of green, 7 different values of blue. So when we're on 0, only red is turned on, 255. So if you go down to this mapping part, we did from 0 to 23, and the 0 to 6 is actually 7 different colors, 7 different positions. And the positions will equate to these positions where position 1 is going to be all red, no green, no blue. And position 2 is going to be red at full color, green at 165, blue at 0, so on and so forth. Position 3, all 3 are on at the same time. I'm sorry. Position 3, 255 for red, 255 for green, 0 for blue. So red and green. It's probably the violet color. And then position 4, red is 0, green is 128, blue is 0, so that would be the green value. Position 5, red is 0, green is 0, and blue is 255, so that's your solid blue color. And so on and so forth. That's what that array does when we're changing the potentiometer to choose from 0 to 6. Okay. Excellent. Let's go to the next section. Next section is going to be creating a nightlight. And how we create nightlight, we'll just leave everything as is as far as the colors go. We'll just pick out a color. How we do the nightlight is the sensor on light sensor A1. So when A1 is on, we want to turn on the light. When A1 is off, we want to turn off the light. And how we do that is through an if-then-else loop, or if-else loop. And where are we going to put that? Well, let's put that, this is where it turns on. So the analog right is where it turns on. So we're going to put an if-else loop in here. Tell you what, we're going to take this, copy it, and we're going to get rid of it. Okay. Let's do an if-else loop. Now, how an if-else loop works? Let's type it down and I'll show you. Should we turn on the LED? And it was if. So IF, that turns the light green if you can't see that. Analog light sensor pin is less than 400. And then we're going to have open close brackets. Now, on a function, and this is a function, you have your function itself, then you have your function arguments, which is inside this, and I missed something here. Analog read. Okay. So we're reading the light sensor. Actually, we want this less than 400. So this is the argument of the, right here, the analog read. That is the argument of the function itself. So you have a function, you have an argument, then after the argument, if it's true or false, you would do what's inside the brackets. So if it's true, we're going to do something inside the brackets. And what we're going to do inside the brackets is we're going to turn on the lights. So turn on LEDs, and we're going to put back the analog lights that were there before. Now, if it's not true, if the analog read is not true, then you're going to have an else. An else is, again, you're going to have open and close brackets inside the else. Else is if this if statement is not true, then you're going to do the else, and the else is whatever's not done. So in that case, we're going to do an analog write. Let's see, we'll start off the red pin, and we're going to call that 0. Now in digital write, we would say low, but in analog write, it's 0. So the arguments on an analog and digital are slightly different. So same thing, we're going to do this in an analog write for the green and the blue pin as well. Let's say with convention, we'll do the green next. I'm going to call that 0. So basically, we're going to turn all of these off. Okay. And is that it? I think that's it. Else loop. Well, let's make it look pretty here. So since these, we'll keep them at the same level. Okay. In Arduino, they really don't, the computer doesn't care about spaces. It just goes to the next line. It does care about semicolons, but does not care about spaces. And after, we're going to delay for about a half second. That way it gives the time for the sensor to recalibrate, if you will. Okay. I think that's all we need here. So let's go through the program again. It's still going to read the potentiometer, and that's going to choose the color. But what we changed in the program here is the light sensor. So if the analog read light sensor less than 400, usually light sensors, it'll have a variable, it reads a variable amount of energy, but if it's less than 400, we're going to say that the light sensor is basically reading 0, and then your nightlight will turn on. So as soon as it reads less than 400, it's going to turn your red, green, and blue LED on to the appropriate color that the pot value was still set at. And if it doesn't, if it's not less than 400, then it's going to turn all of them off. It's going to turn red, green, and blue off, and it should show 0. So let's verify our code. We'll compile it. And we have a mistake. What is the mistake? Light sensor pin was not declared. Constant light sensor pin. Oh, spelled it wrong. Capital L. Okay, let's try it again. Everything's green, everybody's happy. Let's upload the sketch. And it's there. Okay, we've uploaded it, and let's test it. So we'll cover it up, and it turns on. So we're covering up the light sensor, and the light turns the blue. Success! Okay, we've created a nightlight, a variable colored nightlight. So that's a successful program. That concludes lesson 3 on the RGB LED. Again, in review, we've done a color change using an RGB LED and a rainbow array, basically an array of color values for 7 different colors. And then we used a potentiometer to map that, and the value of the potentiometer actually changed the color values to the 7 different colors that we had programmed into the array. We've also added a light sensor to create a nightlight. So it's a variable color nightlight is the final product for this lesson, if you will. So thank you for joining us, and stay tuned for our next lesson, which will be adding an ultrasonic sensor to our Arduino projects. Thank you again.